Hello, in this second video on bearings we're going to have a look at how we can use some of our angle facts to help us calculate bearings. Right, we're going to start off with an example, and I've got 2 points, A and B. I've got my northerly line drawn already above my point A, and the first part of the question asks me what is the bearing of B from A. So I'm starting from A and I want to know what direction I need to travel in to go towards B. So first things first, I need to connect up my points A and B, and oh, that's not drawn very well there. There we go, that's a little bit better. And remember, I always measure my bearings from the north in a clockwise direction, so I'm looking for this angle here. So from the north in a clockwise direction, and I want to know what that angle is. I'm going to need my protractor. So I'm going to line up my crosshairs above my cross, and my verticals should be aligned, and then I'm going to measure, and this time with the outside scale, one that starts from 0, measure it round. I think that's going to be 73 degrees. So 73, but remember it's a bearing, so I need 3 digits, so my bearing is 073 degrees. So this was 73 degrees as an angle. My bearing needs that extra 0 in front, 073 degrees. So we've done the first bit. The second bit says, what is the bearing of A from B? So this time, rather than standing at A and measuring the direction towards B, we're going to be standing at B and measuring the direction towards A. So the most important word in that question is that from. It's telling us which angle we need. We're measuring from B, so that means we need a vertical line, a northerly line above B. If you've got grid lines, that's going to be a little bit easier for you. I haven't, so I'm going to need to make sure these are lined up. Let me put that in here, and we've got my northerly line. What I'm actually going to do as well is I'm going to extend that line a little bit below, and we'll see why I'm going to do that in a minute. So I've got my 2 northerly lines. These are going to be parallel, and I want to work out my bearing of the point A from B. So I'm stood at B. I'm measuring my angle from the north in a clockwise direction. So I'm going to travel round here until I get all the way through to the direction of travel pointing towards A. So I'm interested in this whole angle around here. Well, this angle is more than 180 degrees, so I'm going to struggle to measure that with my little protractor. But what I do know is I know that that angle here is 180 degrees. So if I can measure this one, my bearing is going to be 180 degrees plus, shifting this up a little bit, 180 degrees plus whatever this angle here is. Well, I can measure that with my protractor. So I put my crosshairs on my X. This time I'm going to be measuring around the outside scale. I'm starting at 0, and I've got a value of 73 degrees. So my bearing is 180 plus 73, which is equal to 253 degrees. I've got my 3 digits, and that's looking good. First things first, should I have been surprised that this angle was exactly the same as this angle here? No, I shouldn't, because what have I got? I've got 2 northerly lines here, and these are going to be parallel. They point in the same direction. They're parallel. This line here crosses my 2 parallel lines. So remember, the fancy word for that was a transversal. It's a line that crosses 2 parallel lines. So if I draw on here, it should be a little bit easier to see if I highlight it. I have got a Z shape, especially if I turn it round, it might be a little bit easier to see. I've got my beautiful Z shape there. And I know that these 2 angles here, they're opposite side of my transversal, and they're alternate angles. We know our angle facts, our alternate angles are equal. So if I know that that's 73 degrees, I know that this angle must be 73 degrees as well. So first things first, we've got our angle facts, we've got our alternate angles. I can use that piece of information to find out a missing angle. I also get a really important result, and that is, if I'm travelling from A to B on a bearing of 73 degrees, if I travel in the opposite direction from B to A, all I've done is add 180 degrees onto my original bearing. So 73 degrees in that direction, 253, so just 180 onto my original bearing to give me my reverse direction. So I'm always going to get this result. It's one of the reasons we say doing a 180. It comes from the expression of adding 180 degrees to your bearing or taking 180 degrees away. So if I take my biggest bearing, 253, and I take away my smallest bearing, 73, the difference is always going to be 180 degrees to travel in the reverse direction. So sometimes if my original bearing was slightly bigger, so I had a number like 240, I'd have to take the 180 away to get my reverse direction. But always the difference between those two numbers is going to be 180 degrees. Okay, let's have a look at another example. This time, a little bit more complicated. I've got 3 points. I've got A, B and C. I've got my 3 northerly lines already marked. And I've got a couple of angles. I've got my angle here. So this would be my bearing of B from A. So I'll be measuring it from the north, clockwise direction. So the bearing of B from A is 50 degrees. And I also know that the bearing of C from B, so I'm starting from B, measuring clockwise, 120 degrees. So my bearing of C from B would be 120 degrees. But I don't know what this angle here is, and I've been asked to work out what it was. So it would be the angle, the amount of turn that I'd need to go through. So instead of pointing at C, to point at A instead. So I've been asked to work out what that is. I don't know. But what I have got is, I've got 2 northerly lines on here. I've got this one, and I've got this one. And they're connected with this transversal, this line that crosses between 2 parallel lines. And it's formed up a C shape. Again, if I turn that on its side, sometimes people find that a little bit easier to see. I've got this C shape. So I know that the 2 angles inside my C are called co-interior angles, and I know that they sum to 180 degrees. So I know that 50 plus this equals 180 degrees. So this angle here is 180, take away 50 is equal to 130 degrees. So this angle must be 130 degrees. So I've now got angles around a point. I've got 130 there, 120 there, so if I add those together, let's do it here just to make sure. 130 plus 120, that's going to give me 250 degrees. So the missing angle has got to take me up to 360 degrees, angles around a point. So 360, I'm going to take away 250, that's going to leave me, shoved it up a little bit, 110 degrees. So the missing angle is 110 degrees. I've needed to do 2 steps. First of all, I've used my co-interior angles, remember sometimes we call them supplementary angles, and the fact that they sum to 180. So if that one's 50, this one needs to be 130, so that 50 plus 130 gives me 180. I can then use angles around a point equals 360. I know these 2 now, so I can work out what the missing angle is. They haven't really asked me very much about C, but I could work out some other angles. I know that if that's 120, I've got another C shape here. So I know that this angle plus this angle down here must add up to 180. So 120, if that's 60, 120 plus 60 is going to give me my 180 degrees. So I know that's 60. Actually, I could work out what that bearing was, because it would be 300 degrees. 300 plus my 60 would give me the 360 angles around a point. So for the questions that you're going to try now, two things are going to be really important to you. One is going to be these co-interior angles, so look out for those. There's going to be loads of these co-interior angles, and you're also going to get lots of these angles around a point. Pretty much with those two facts you can solve pretty much all of the questions within the exercise. So we've got our parallel lines. Wherever we've got these northerly lines, we've got parallels. Lines that connect them, our transversals, are going to give us lots of angles in parallel lines. Angle facts that are going to be really useful for us today: co-interior angles summing to 180, and angles around a point summing to 360 degrees. Okay, have a go at the exercise and good luck.